Welcome to Module 3, Lesson 6, Collecting Rational Number-like Terms. Okay, so we're going to deal with these like terms, and when they specifically mention rational numbers, we are going to be working with fractions, finding like denominators, etc. So it could be multi-step. Just get ready to be inundated with fractions. Okay, so here we go. Okay, so here this opening exercise asks you to solve each problem, leaving your answers in standard form. Okay, that's going to be just to come to a complete answer at the end. All right, and go ahead and show your steps. Do not just put an answer down. All right, there's I think numbers 1 and 5 are word problems, and the others are just expressions that you need to get to standard form. Okay, multiple steps need to be taken. So go ahead, good luck, and come on back.
Okay, so here we are back. I'm going to look at the opening exercise. Here's number 1. A little bit of a word problem here. Terry weighs 40 kilograms. Janice weighs 2 3/4 kilograms less than Terry. What is their combined weight? And again, we have Terry here. This in the parentheses would represent Janice, because she is 2 3/4 kilos less than Terry. Okay, and it's a very popular way of writing problems out is to use the parentheses using this algebra here. Well, it's more or less not so much algebra, but it's just using the parentheses. So that would move over there. Then you have your 40 remains. That's your 40. This 37 1/4 is the actual answer to the parenthetical part. And then just add those two together, and you get 77 1/4 kilograms. Okay, and here we go. So number 2 is just a straight out problem with mixed numbers and a fraction there. First thing to do, step 1, just make them all into fractions, whether they be improper or proper. Okay, and then of course find your, so change to fractions. Okay, so that means take them out of mixed number form, and then you're going to find LCD, lowest common denominator. In this case that was 30, as you can see right there, and you're going to change those from thirds to 30ths, halves to 30ths, and fifths to 30ths. Okay, and if you did that, and you had your 80 minus 45 minus 24 is 11, and then you have 11/30 as your answer. Number 3, pretty easy. You just have a whole 4 negative, and just take away a positive 1/5, or add a 1/5 to it. Okay, because then you are moving again to the right of the number line, more towards the positive side. So your answer, of course, is a less negative than the -4 that you started with. Now you have -3 4/5. All right, number 4. This is a product here, and that stands for 4 times 3/5. You can rewrite that this way: 4 over 1 times 3 over 5, and then you just multiply across. 12 over 5, 12/5, which simplifies down to 2 2/5. Okay, here's another, our last number 5 here is another word problem. Mr. Jackson bought 1 3/5 pounds of roast beef. He cooked 3/4 of it. Very, very important here. 3/4 of it. How much does he have left? Okay, I'm wondering right now if some of you just went ahead and did 1 3/5 take away or minus 3/4, okay? Because this does not say 3/4 pounds. It says 3/4 of it. So that it refers to this 1 3/5 pounds, okay? That's what that it is. Therefore, what we need to do is to take our, his beginning, the original 1 3/5 pounds of beef that he bought, and then we're going to subtract away 3/4 of it. And again, remember that word of means multiplication. Okay? Multiplication. So here we have 3/4. We're going to take this and we're going to subtract away all of this right here. Okay? And when I do that, of course I leave this the same here. And now I have 3/4 times 8/5. And what I've done is just taken this, just like I did before, just turned this mixed number into an improper fraction. Okay, and then that is going to be, then I am going to multiply that over, and I get hold on a second. Whew, sorry, I was just trying to figure out what I did here. Okay, yeah, this 8/5 here was confusing me. That 8/5 is this right here. Okay, so I have 8/5 take away 24/20 because I've done the multiplication of this. All right, and now I need to again to convert into like fractions. So I have the 24/20 already, and then I can just turn my 8/5 into 32/20. Okay, and 32/20 take away 24/20 is 8/20, or 2/5. Okay, because 8/20 is the same as 2/5, so 2/5 pounds of meat. This is what I have left, or he has, Mr. Jackson has left over. And again, this problem is because if you did do it incorrectly first, because you just misunderstood what this 3/4 was standing for, very, very important, and it just just shows you it's a testimonial to the real need, or the real importance of knowing what to do with the numbers that exist in your word problem. Okay. Okay. Now here in this example 1, we are asked to rewrite the expression in standard form by collecting like terms. Okay. Now this, as we know, this lesson is aimed at understanding that a little bit better, but we have done it in the past, so it's not anything you haven't yet done. So if we look at all of these terms here, they are all n, okay, all n, which is helpful. Okay, so these are, we're just going to join these all together, and you're going to have one term at the end of it all. Okay, so first thing we would need to do, of course, we're talking about fractions and mixed numbers. Go ahead and first of all we do have the one mixed number, so we should go ahead and alleviate that, okay, because that would be a first step. We could just rewrite, and let's go ahead and rewrite as a sum as well. So we'd have 2/3 n. Let's do plus negative 3/4 n plus 1/6 n plus 18, that's 29 n. Okay, so you can see what we've done here. I've just rewritten this as sums. I took my one negative term right here and just made it into a sum of a negative. So we can now very easily take these and move them around. So what we need to do now, of course, is we need to find an LCD, the lowest common denominator. Okay, and I usually would suggest to everyone to begin with that, to begin with your highest denominator. Okay, so 9, and then we have 9, 18, just looking for denominator or multiple. It's going to fit into, it's going to be divisible by all of these. 27, 36. Looks like 36 will be it. 36 is our LCD because all of these denominators here are divisible by all of these denominators. So we have 36 plus negative something 36n plus 36th n plus 36th n, 39, 36, there's 36 here. Okay, so now we'll go ahead and just change these. So this is going to be 12, this is going to be 24, 36, here we have 9, we have 27, 36, 6, 36, and then 80, 36. And now it's just a matter of just working with these with the numerators here. Okay, we know our answer is going to be something over 36n, okay, because our variable is not going to change, okay. So we do that, we have 80, we have all of our positives first, so 80 plus 6 is 86, plus 24 is 110, and then 110 take away 27, that is 3, that's 83. So 83 over 36n, which is also then 2 and 11/36 n. Okay, so that is our final answer right there. Okay, for this exercise 1 here, this is an interesting one. I like this idea. It says, for the following exercise, predict how many terms the resulting expression will have after collecting like terms. And you can see up here that we only had one term left at the end. We had one term, okay, because they were all n's. You know, all were n's, so they were just one type of term. So we ended up with one term in our final answer. Okay, let's go ahead and predict that here. If we look at A, and let's just go ahead and just do these together, easy enough, because you can see the different types. We have G, we have 2/5 G here, we have a negative G here, we have 3/10 G there. Okay, so we know this G term is going to be there, and then we also have negative 1/6. And we have negative 4/5. Okay, so we have two types of terms, or two terms at the end. Okay, so this one is going to be 2 terms. Okay, because you can see at the end it's going to be something plus something, or something minus something. Okay, some G term minus a fractional term probably. Okay, and then if we look at this one, B, we can see we have an I, and 6i there, and negative 3/7 I, and then we have 1/2 I. Okay, so we have I, and then we also see that we have a few H terms as well. Okay, so this is going to have 2 terms as well. So both of these, despite the fact that there are, what do we have here? 1, 2, 3, 4, 5, 6, 7 different terms, and over here 1, 2, 3, 4, 5 separate terms. Okay, they're both at the end are going to look very similar because they're both going to have 2 terms. Okay, so now what you can do by yourself is go ahead and write the expression in standard form by collecting like terms. So go ahead and do that and come back and we'll check it. Okay, for A here, what I did first, if you notice, and hopefully you're doing going through a similar process, I went ahead and used my my associative and commutative properties and moved things around. Okay, any order, any grouping, any group, any order, something like that, right? Anyway, I went ahead and just put all my G's first. Okay, lined them all up, right, and then I had my two fractional terms, and then I went ahead in that next here. So right here, what I did is I went ahead and found LCDs, lowest common denominators, for both of my two different terms. I use tenths for my G terms here, and then 30ths for my fractional terms. And then very simply what I did is just combined my like terms. I had 4/10 G and 3/10 G. That was 7/10 G, and then I had a whole negative G, so that turned out to be negative 3/10 G. And then I had negative 5/30, negative 24/30 was a negative 29/30. Okay, so I can just write that final answer would look like that there. Okay, and for B, I did B over here. As you can see, I just transferred it over here where I had a little more room. Okay, first thing I did is I went ahead and grouped my my like terms all next to one another, all my I's, and then all of my H's. Okay, could have done it the other way, all my H's and then all of my I's, which might have been preferable, just because, like I've said before, you try to keep them in alphabetical order. That's generally how you're going to see these terms. Okay, so but what I did here then, as I went ahead and just wrote it as sums, a series of sums. Okay, I go over here and over here. Again, I like doing it this way. It just shows me that I have a negative H, I have a negative 3/7 I. When I'm combining my like terms, makes it much easier. In the next line, I went ahead and found lowest common denominators, least common denominators where I needed them, and that was over here with this I at 14ths. It was my lowest common denominator there, and then with my H's it was 12ths. Okay. Combining like terms, went ahead and did that. Ended up with 7 and 1/14 I and a negative 5/12 H. I could write it that way, or this would also be correct. Okay, example 2 here is a word problem, and word problem very, very worthwhile going over together, doing this together, because there is a lot going on here. Well, actually, it seems like a lot, but if we just do it step by step, it'll be a lot easier. So, at a store, a shirt was marked down in price by $10. Important information there. Excuse me. A pair of pants was doubled in price. Okay, so we've got this marked down by $10 for the shirt. The pants doubled in price. Okay, so following these changes, again, it's not a very well worded problem either, but following these changes, the price of every item in the store was cut in half. Okay, cut in half. So imagine this: you've got Christmas sales, etc. Oh, for Christmas, the shirt was marked down by $10, but the pants doubled in price. Maybe they were very, very popular, and therefore they wanted to raise their price to get as much money as they could. Now the season's over. I mean, the holiday season's over. It's after Christmas. People aren't as hot for buying things, so the price of every item in the store is cut in half just to get everything out. Because what happens is that retailers, they want to get rid of their stock and their inventory and to bring new things in. Okay, so that's the kind of situation you would have here. But what they're asking us to do right now with these bits of information is to write two different expressions that represent the new cost of the items. We're going to use S for the shirt and P for the cost of the pants. Okay, so first of all, let's just look at this. So we have a shirt here marked down in price by $10. Okay, so if S is the cost of each shirt, this scenario would be S minus 10. Okay, so that's price of the shirt minus 10. Now with the pants was actually doubled in price. The pair of pants was doubled in price. So we have, so if a pair of pants is, the price of a pair of pants is P, then doubled in price would be 2P. Okay, so this is the situation we had before the drastic cut in half. Okay, so if we were going to write an expression that represents the new cost of the items, okay, so for example, we have over here the shirt, we have S minus 10, and then if that was cut in half, then all we would have to do is put a 1/2 in front of it. Okay, that would be our first expression for that new cost, because now we have our that original S minus 10 sale, and then we have half of that. Okay, now for the pants stays as 2p, of course, just like the S would have, and now we have 1/2 there. Okay, again, it's that price, that doubled in price pair of pants, and then 1/2 there. Okay, now another the next way to write our shirt expression would be, of course, if we went ahead and just distributed. So if we distributed 1/2 times S is 1/2 S, 1/2 times negative 10 is negative 5. Okay, and now we have a second way of expressing this situation, the new cost of the shirts. Now for the pants, same thing, and now here we actually have the additive the multiplicative inverse of 2 is 1/2, and of 1/2 is 2. Therefore, we know this is going to be 1 here, 1p, more popularly known as just good old p. Okay, so we have two ways of expressing the new prices using expressions. Okay, really super helpful in life. It truly is. Okay, this exercise 2, I'm just going to treat like an example, and I want to do this together. Okay, so now it asks you to take those, to take the information from the example we just did, and write two different expressions that represent the total cost of the items if tax was 1/10 of the original price. Okay, 1/10 of the original price. Now, tax is going to be added on. Okay, so you always add tax. Okay. All right, so we had our for shirts. Let's talk about shirts. We had an expression that looked like this: 1/2 S minus 10. Okay. Now, what's important here is that the tax, and this is silly, but anyway, we'll deal it anyway. But tax was 1/10 of the original price. Okay, the original price of the shirt. So we're going to add then 1/10 S. Okay, because right here we have the half price sale, we have the original price of the shirt, we have the $10 off, and now we have the tax on the original price of the shirt, which is 1/10 S. I don't really know that this is ever a real scenario. They don't usually do that, but anyway, they just want to see if we can write an expression. Okay, and that is how we would write that expression, the shirt. Okay, we can go further, of course, because that would be just one scenario, or expression 1 right there. I was trying to write the number 1 there. Okay, this would be one expression. And now if we wrote this again, of course we could just go through our steps. We could do our distributive. Okay, and we know that is 1/2. Let me forget 1/2 S. 1/2 S minus 5 plus 1/10 S. But then we can go ahead and find the lowest common denominator, and that would be 10. So we would have 5/10 S minus 5 plus 1/10 S, of course. All right, and let me see. Is this right? Am I doing this right? Hold on one second. Yes, that's right. Is that right? Yes. Okay. I'm sorry. But anyway, yeah. So then we can just combine these two, and what we have 6/10 S minus 5, or 3/5 going into lowest terms there, minus 5. Okay, so this would also be the second right here, the second way we can express this whole scenario of the half-price sale of the already discounted shirt, half-price sale of the already discounted shirt, along with the tax on the original price of the shirt. Okay, and that was one way to express that, a pretty clear-cut way. And this way just combines like terms and becomes that, and it's really in its simplest form. So what I will have you do then right now is, why don't you go ahead and work with the pants problem here, okay, and go ahead and do the same. Do what I just did here for the shirt, and then do it on your own. Come on back and check it out. Okay, so hopefully you got here what I got. I just went ahead and wrote my 1/2 times 2p like we had from the previous example, and added on my 1/10 p. I went and distributed and got that for the distributed part, or actually the p for the distributed part, and then added the 1/10 p, and then I also had 1 and 1/10 p. Okay, so these are equivalent. This one, of course, the second one has all like terms and is what we would consider more simplified. Okay, so we're going to do this example 3 together, and then I will give you exercise 3 to complete on your own. What I would like you to start doing, though, at least every 1 or 2 different expressions that we work with, please do justify each step that you do by writing the explanation to the side. I'm going to go ahead and do that this time. It'll take me a little bit longer to do this, but bear with me. If you're really irritating you, just move on. Okay? So I want to go ahead and write this expression in standard form by collecting like terms. So I want to show you the first step. And again, we talked about this already. I already mentioned this, but it bears mentioning again. It's worth mentioning again. First thing I want to do, and I will always do, and hopefully I could get you to do this as well, I want you to write all the mixed numbers as improper fractions. And let's just get that out of the way. So let's go ahead and do that right now. So 5 1/3 is going to become 16 thirds. Okay, and I want to go ahead, let's just get this out of the way too. Let's just go write these as sums, okay, which is so much easier. And 3 1/3 is -10/3, -10 thirds. Okay, and we are going to then add 1/2 x, or actually we are multiplying 1/2, of course, 1/2 x, and then we have plus. Okay, so hold on a second. Let's re-look at this. So if we look at this right here, let's just I wasn't actually aware. I needed to look at this a little bit more closely, but we have actually two expressions here. We have 5 1/3, which is now represented as 16 thirds. Now this, and then we're subtracting, okay, all of this here, but we're going to add it as negatives. But then this whole thing is going to be, we're going to distribute that eventually. Okay, I'm going to distribute that eventually. So in this case, we have 3 1/3 times -3 1/3 times 1/2, which is the same as, -10 thirds times 1/2 x. Okay, and then we're going to add that to, again, -10 thirds times -1/4. Okay. All right. So again, let me just show you that again. We took this one here, and this 5 1/3 here is represented here. Okay, and then this is one part. This is one of the expressions, and this is a whole expression here. So we're actually going to find the sum of these, even though it was originally a difference, but we're going to use it as write it as a sum. And now I just started I took 3 and negative 3 and 1/3, okay, which is this right here. It was a minus 3 and 1/3, which is the same as plus negative. Okay, now this is, I didn't mean to do that. This right here, that negative 10 and 10/3 is going to be multiplied, of course, by 1/2 x, okay, which is right here. And then it's also going to be multiplied by negative 1/4, which is here. So we've actually done a number of things here. We have write mixed numbers as improper let's call them imp fractions, and then distribute. Okay, we could have made that 2 steps. Might have been a little less confusing, but you can see I've actually done 2 things there at once. Okay, now what I want to do is I want to go ahead and I can do a little. Actually, I don't need to do any regrouping at all, but they're going to stay the same. But let's just go ahead and do this multiplication here. So this 16/3 is going to stay the same. Added 2. Let's go ahead and multiply negative 10/3 times 1/2 x. That's going to be negative 10/6 x. Okay, and then we're going to add that to negative 10. Actually, it's going to be a positive because this is negative times a negative. You can see this. So we're doing a negative 10/3 times a negative 1/4. So that's going to be positive 10/12. Okay, so that's what we have there. We have that. So let's go ahead and then find a. We actually don't need to work with the x anymore because we have one term here. There's only one x term. We do have this 10/12 and this 16/3 to deal with. So if we make those into like fractions, that would be those would be 12ths here, and that would be 12ths for 64, right? 64/12 plus 10/12 plus negative 10/6 x. Okay, then we would go ahead and add those together, and then we have 74/12, okay, plus negative 10/6 x. All right, and now of course we can simplify all of this, and let's go ahead and put x at the beginning, okay, at the beginning, and the number at the end. So negative 10/6 simplifies down to negative 5/3 x, and then we're going to add, and that actually goes down to 37/6. 74/12 goes down to 37/6. And again, why this is a preferable order is because we have our variable, and then we have our number, a rational number without a variable at the end to finish off. Okay, so here in exercise 3, go ahead and rewrite the following expressions in standard form by finding the product and collecting like terms. Okay, so again, pay good attention here to the fact that that is a product right there. Okay, and that is a product right there as well. So go ahead and use everything at your disposal, all of the properties that you've come to learn. Go ahead and solve both of those, and come back and check your answers. Okay, so here we go, and I will again, if you want to just pause this, check the answers and not listen to me yap, you can do that, or you could listen to me yap. Anyway, again, like I like to do always, this first step here is like a two-stepper. What I do is change all my mixed numbers into improper fractions, as well as do my distribution right here. So I've distributed here negative 1/2 times 1/2, and then negative 1/2 times y. Okay, and that comes from right here. Okay, and again, I'm writing those down as sums. Therefore, I have my addition, and then I put my negative inside here because that's a negative 1/2. Okay. All right, and then continue on. This doesn't change yet. I do my multiplication here and get negative 1/4, negative 1/2 y, and now I'm going to be doing some combining. So I want to find my least common denominator of my fractions here, and this 12ths, and then I went ahead and just converted those into 12ths and kept this, and then just final answer, just turned it all around and had my negative 1/2 y at the beginning, and then I'm subtracting away again because it's negative 79/12. Okay, and that was adding these two. Or another answer that would be correct would be negative 1/2 y minus 6 7/12. Okay, so either one of those is correct. All right, down to the next one, B. Same thing. Actually, no, I didn't do the same thing. I didn't need that mixed number step, so I just brought everything down but did my distribution here. And one thing you can notice here is that here my my 1/3, which I'm distributing, is actually a positive, so I don't need to mess with that. But I do need to pay attention to the fact that this right here, this negative 1 1/3, stays that way when I well, actually I did change that. I did change that one mixed number into a improper fraction. Okay, but that's where the negative sign is going to reside now. Okay, and then went ahead and did my multiplication here. Got 1/12 f, and then my negative 4/9. Then changed. I saw that I had already had 4/9, so I could change thirds to the ninths. I knew that. So then I had my 6/9, negative 4/9, and then 1/2 f, and went ahead and wrote those like this: 1/12 f plus 2/9, which is the combination of negative 4/9 and 6/9. Okay, this example 4. This is a bit of a leap in understanding. Hopefully, this is just the beginning. So we will see this type of thing over and over again. But what they want you to do here is model how to write this expression in standard form using the rules of rational numbers. Okay, and what you can do with rational numbers, especially, of course, we're talking about fractions. Okay, now I will get into this further, but one thing that you should know, if you don't know already, is that this right here, well, not just this, but we'll do one at a time. There are equivalent ways to write all of these fractions here. Okay, all of these fractions. Now, x over 20 is the same as, I'm just going to write here for now, is equivalent to 1/20 x. Okay, so very, very important, because what we're assuming here is that we have one x up here. So if we divided x divided by 20, we'd have 1/20 x. Okay, 1/20 x, because when that 20 is on the bottom there, that is 1/20. And the same here for 2x over 5 could also be written as 2/5 x. Okay, and these are rules of these are the rules of rational numbers that I was referring to. Okay, so just so you know that, and to have that in mind. Now, that is when you have two products. When you have a product on top, as you can see, we had x, and then we had 2x. Okay, you use pretty much what you're using is that using x as a fractional piece. Okay. Now this one here, though, x plus 1 over 2, is actually a sum, but what you can do with that is you can split that up into pieces, okay? And that could be x over 2, or as we saw over here, that could be actually be 1/2 x, okay, 1/2 x, and then plus 1/2, okay? Because you take these two separate parts of the numerator and they become, actually you could become two separate terms here, okay? When you have you use this one denominator to apply to both of those numerators, okay? And the same this is the same here, 3x over 10, okay, which is the same as 3/10 x, and then minus 1/10, okay? And you can see right here you have your 3 and you have your 1, which are up here, okay? But you have your x, which is now resides here, okay? So these are part of the rules, and again, we'll see these a lot in the future, and hopefully you will understand this better as we go along. If you don't understand it entirely right now, I absolutely understand, okay? So let's go ahead and do this together, and we'll do two different ways. We have two different boxes here. We'll go ahead and do it two different ways. Okay, so firstly, we won't bother with rewriting those first of all. Okay, we won't write these as two separate terms, okay, like I had just finished doing. We'll go ahead and keep them as they are right now. So if we keep them the way they are right now, one of the first thing we want to do is we actually want to, like any other fraction, when we are adding fractions, we notice one thing that is a problem here. We can't add any of this, of course, because we have 4 different denominators, okay? So what we need to do here was to find an LCD, get lowest common denominator, just like we always would, okay? And so we can see that LCD is 20, okay? So we're going to be working in 20ths. So let's just go ahead and do that. Let's put all of our 20ths down. Okay, plus 20ths. Okay. All right, now this one stays the same, of course, right here, x over 20. Okay, this, because that doesn't need to change, it already has 20 in the denominator. But we're going to have to change this numerator here, this next numerator, and we do it exactly the same way we would in just a regular fractional situation. Okay, we're going to find that 20 divided by 5 is 4. Then we're going to multiply the numerator by 4, and that's going to be 8x. So now we have 8x over 20. Okay, and we could actually, if we wanted to, maybe if this makes it a little bit better, maybe we can just go ahead and I can maybe just show you that. Let's just take it one step at a time. Okay, because we can see that we need to multiply by 4. Because it was fifths, and we have to multiply by 4 to get to the 20ths. Okay, so we'll just keep it like that. Now with the 2 in the denominator, we're going to have to multiply by 10. So we have 10 x plus 1. All right, and now with the 10, we'll have to multiply by 2. So we have 2 3x minus 1. Okay. So now they're all 20ths, all right? So at the next step, we could just go down and we could just put one of the 20. We just put 20th right in the middle there, all right? Because that's going to represent everything. Because just like if you're multiplying, 1 6 plus 2 6 plus 3 6 plus 4 6, you're only going to have 1/6 at the end. So we have 20ths, and let's go ahead and just put these up here. So now we have x, and now we have plus an 8x. Okay, I'm doing the multiplying now, multiplying this out. And then we have 10x plus 10x plus 10, okay? And that 10x plus 10 comes from here, 10 times x, and then 10 times 1, okay? Plus 6x minus 2, okay? So now we have taken all of this here and distributed out our numerator, okay, all of our numerators, all right, and they have now appeared down here, okay, so we're using distributed property as well, okay. Now we need to combine like terms, okay, we have two types of terms. We have x's and we have just regular numbers, okay. Our x's, we have 1x here, plus 8x, that's 9x, plus 10x is 19x, plus another 6x, so that is 25x, okay. And then number-wise, we have 10 right here, and then a negative 2, that's going to be 8, so plus 8 over 20. Okay. So now we again can treat this as, no, well, not again, we haven't done it here yet, but as we will be doing in the next solution, we can go ahead and treat this as actually the same as 25x over 20 plus 8 over 20. Okay, because this is actually two different terms here. Okay, so then that we can now do a common factor, just simplify both of these. And if I simplified the 25 over x over 20, that would be 5x over 4. Okay, plus 2/5. Okay, because 8/20, if you divide both by 4, you get 2/5, and then 25/20 if you divide both. As I multiply them and divide both by 5, you'll get this here. So, and again, this could also be 5 over 4x plus 2/5. So this would be a final answer right here. Okay, final answer. Now that's one way to do it, by just keeping everything intact and then working with the lowest common denominator first. Okay, and now we're going to do it a different way, and I don't want to erase, so I'm going to go find another sheet of paper, so to say. Okay, so here we have our original expression. Okay, so what I would like you to do now, or what I will do with you now, is to do it a little bit different way, and this way is related to how we finished up that last problem and what I had told you about the rules of rational numbers and how they work. So this is, this x over 20 is equivalent to 1/20th x, okay, and then we add, and now we have the 2x over 5 is equivalent to 2/5 x, okay, and then remember when we have the two expressions up top, the x plus 1, we have a sum up top. This is the same as 1/2 x, okay, that's this part, okay, 1/2 x plus 1/2, which is this part right here, okay, plus, and again the same thing here, we have 3 over 10x, then we have minus 1/10, and again that 3 over 10x was, we're using these, and then the negative 1/10, we're using those, okay. So now we've gotten to this point, we can just go ahead and then just line everything up here very nice and neatly. We could put all of these x's into a parentheses. Okay, so again without the x, I'll show you what I'm going to do. Plus 1/2, then plus 3/10, and then all I have to do is put an x, put my x right at the end of the parentheses. So I can just add all of these up, and then I know x, the variable, will be after them, and then go ahead and add just my regular old fractions, 1/2 minus 1/10. Okay, And then if I do that, I'm going to go ahead, of course, as we did already, I'm going to convert everything into 20ths because that's my LCD, same as it was before. And you can see that all these fractions are looking very familiar to you, I'm sure. Plus 6/20ths, all this is x, plus 5/10 minus 1/10. And again, I've done my conversion there as well. I'm using my LCD of 10 for those regular fractions. And then if I add all this up, I come up with again 25/20ths x, which is also 5/4 x, plus 4/10, which is also 2/5. Okay, and here I have my final answer, which is the same as that final answer. Okay, so two different ways, and again, just an introduction to these two ways. There will be plenty more to come. So now to prove we are correct here, there will be times when you will be asked to evaluate the original expression and the answers, okay, when x equals 20. Okay, so this is what we came up with our answer in standard form, was this right here. Okay, 5/4 x plus 2/5. Now our original expression looked like this a lot longer. Okay, so if we're going to evaluate, you remember what evaluate means. It's now I'm going to when you evaluate using a certain number. In this case, we're going to use x as equaling 20. Okay, x equaling 20, and what that means is to simply plug 20 in everywhere you see x. Okay, and so I'm going to go ahead and do that over here. Do that over here first, and we'll watch this play out here. 20 over 20 plus, that's 40 over 5 plus 21 over 2 plus what's that, 59 over 10. Okay, and you see how I did that. If I plugged in 20 for right up here, 3 times 20 is 60, minus 1 is 59. Okay, you saw that. Over here we have x is 20, so 20 plus 1 is 21. And then here 2 times 20 is 40. Okay, and then 20, of course, right there. Okay, so now I have all of that. All my numerators are set. Okay, I have no more x. Okay, my variable is gone, of course, because I plugged in my 20 for it. Now, of course, I have to again create my my common fractions, my like terms. Okay, and I'm using 20ths, so that's 20/20ths. This is going to be 160 20ths, and this is going to be 210 20ths, and this is going to be 118 20ths. Okay, and if I add all those up, I'm going to go away and add them, come back. Okay, I went ahead and just finished it up as well. So I added all those numerators up. I got 508 20ths, which is the same as 25 and 8 20ths, which is the same as 25 and 2/5. Okay, so that is my answer based on when x equals 20. Okay, so right there, when x equals 20, that is my answer. That's how it evaluates. Okay, now let's go ahead and see what happens over here after we use our standard form expression that we created by combining like terms, etc., etc. If we just go ahead and plug in 20 for both of these, boy oh boy, is this easy. And what do we have? We have, that's 100 over 4 plus 2 over 5. 100 over 4, you can see already, is 25. 25 and 2/5. Woo! Okay, the fact that the answers are the same is a very good thing, okay, because that means the original expression worked the same as the as our answer, okay, answer in standard form. So those are good. But the question is here, which one is easier? Of course, standard form is easier. That's why you will always be asked in algebra to find standard form. And again, standard form is pretty much at its simplest when you have just two, well, not two terms, could be 3 terms, 4 terms, but you have a number of terms all just combined, okay? Over here we had, with our original, we had x's all over the place, okay? A bunch of x's being added together. Here we have one x term and then one just regular rational number term. Okay, this last exercise here, exercise 4, I asked you to rewrite the following expression in standard form by finding common denominators and collecting like terms. Okay, so why don't you go ahead and give that a whirl and come on back. Okay, so here I'm on a new page here, so I had enough room. These take a lot of room. I hope you're finding you have enough room in your binders. But here's the original expression. Okay, and you were told to find common denominators and then collect like terms. So that's the way we were going out to handle this. We see our LCD, lowest common denominator of those 3 numbers, was 18 or is 18. All right, and so then just go ahead and write it as a distributive problem, like we did here. To change, of course, changing thirds to 18ths, I need to multiply by 6. And then I just wrote it there in a distributive fashion. Same here, to go from 9ths to 18ths, you need to multiply by 2. To go from 6th to 18ths, need to multiply by 3. Okay, so hopefully you see what I did there. And then since they are all 18ths, they're all like fractions. 18 is the only denominator we need. Go ahead and do our distribution, and then 6 times 2h is going to be 12h, okay, and then 2 times h is going to be negative 2h because we have our negative here, okay, and then we have 3h minus 4 is going to distribute out as 3h minus 12, okay, 3h minus 12, that's 3 times h and then 3 times negative 4, okay. All right, so there we go. We have all of that, and now all we need to do is to combine like terms, and when we do that, we get 13 h's, okay, and we get a negative 12 over 18. Now that can, of course, be split up, okay, into 2 terms. So we have 13 over 18 h, okay, and that's this part here, okay. And then we have minus 12 over 18, which is this part here, okay? And that can actually be further simplified. Not the 13/18 h, because that stays the same, can't be simplified. But the 12/18 can be simplified into 2/3, dividing everything here by 6 over 6. Okay, and that's your final answer. Well, this final example here, and I'm sorry the exercise wasn't the final one, but this is actually considered an optional example. I'm going to do it. If you don't care, just move on and go ahead and start your problem sets and your exit ticket. Okay, so they're asking you here to rewrite the following expression in standard form. Now, what they want you to do is to take a look at it and decide how you might actually begin to solve this problem, okay? And there are a number of ways, okay? A number of ways to start. As you can see, they have they've shown a few here. You want to rewrite it, okay? So we could use a distributive property, okay, to rename, and you can look right here. They have done that right here. The 6x minus 8, okay, is a rewriting using the distributive property, okay. They have also gone and done it a couple of different ways here. I don't notice that they've used a common denominator right away. It looks like here, actually, it looks like a common denominator right here. But what is interesting is that they've changed that 2 times 3x minus 4 right here over 6 into 1 times 3x minus 4 over 3. So they've actually gone ahead and cut that in half. I'm not exactly sure why they did that, but I do understand why they are doing the second step, because they're actually because 24 was going to be the lowest common denominator, even if you kept it with sixth and eighth. So not quite sure, but with this one, yeah, they did go ahead and do the common denominator, the one we just did, and we have been doing, and going over down, zoom, zoom, zoom. Not going over this very accurately. A little bit weary, and I'm sure you're weary as well. But if you want to, you could just go ahead and take a look at those methods, 1, 2a, 2b, and 3. Not that I truly understand them entirely. I do see what this changing of this 2 to 1, I don't know. It's kind of weird. But anyway, there is one more thing here. They have this write the following expression in standard form. If you want to go ahead and give that a whirl, go ahead and give it a whirl. I will solve it myself and then come back and have the answer for you. Okay, and here is this problem solved. I went ahead and found the common denominator of those two, and of course, bringing up my 5 and my 2 here to change my fourths to 20ths and my tenths to 20ths. Went ahead and distributed everything. Looks a little bit like that. Then I went ahead and added everything together to get to this finally, and then came to this, and then finally simplified to that. Well, in closing, I just want to say that practice makes perfect with this process now. We are actually we're moving into a little more complicated territory, and what has really made it more complicated is the fact that we are now combining like terms with coefficients that are no longer just single integers. Okay, they when you have your fractional components, you have fractions of different type fractions, fifths and tenths and thirds, all of those. So there are usually more steps, okay, and those steps include, finding the common or the LCD, lowest common denominator. Okay, just always remember a good first step, finding those lowest common denominators, and you're going to have to then distribute. And you've been doing this for a long time, but you're going to be you have to distribute the numerators, okay, and then you're also going to be doing a lot of converting of mixed numbers to improper fractions. Again, these steps are all to make the process easier, because it is a complicated process. You make it less complicated when you take care of these things first. Okay? And yeah, and again, following the process, and that's it. The process is the most important thing. If you're going to get a few wrong here and there, that's not a big deal. The big deal is to learn the process and get confident with it.